hold on. Steve, sorry. Guys, come on. One more time. Come on. Take it away, Steve.
All right. Man,
now that was good.
I feel pumped now. All right, I'm ready to do this. All right, everybody, this is writing custom Angular builds. Are you ready for this? All right. So before we start, let me just tell you about myself real quick so you know who's talking at you. My name is Steve Belovarich. I am a manager UI engineer at Symantec right now, where I build UI libraries for the company as well as build tooling that engineers use throughout consumer and enterprise applications. In my free time, I make art with electronics. It's fun. That's why maybe my first slide is a bunch of glitchy stuff from the 80s, right? So I've been building Angular with custom scripts ever since it was in alpha, where I started with a gulp file and then branched out from there. Today, we're going to learn how to write a custom Angular build. So why would we want to do this, right? Well, you know, the Angular CLI is there. It's great at a lot of things. You know, it uses Webpack, and it's getting way better at integrating with other things, but there may be a use case where you need to integrate with some other tooling, or you need to pick up Angular and make it work with something that the CLI just cannot do. So that's probably the time you want to write your own script. Another reason why you might want to write your own custom build is you're excited about new features in Angular and they haven't been rolled into the CLI yet, and you want to start using them now, right? So for instance, when Angular 5 came out, Angular 4 last year at ng-conf, I was able to write a script to build the package format that was announced. I did it while I was at ng-conf that year. So I could go back to my company and we could build libraries using the package format right out of the box. We could even generate libraries through a custom script, which that feature just landed in the CLI. So yeah, you might want to enhance the overall experience for development. I'll show you some examples later in this presentation about how we can prettify logs from the compiler, you know, make it so the overall experience for your development cycle is faster and more efficient, possibly. Maybe you just want to know how this works. You know, maybe you just want to know how Angular is compiled ahead of time, how you can use the compiler CLI. Maybe you're excited about Closure Compiler. Is anybody excited about Closure Compiler in this room? Raise your hand if you want to use Closure Compiler, find out more about it. Cool, you're going to find out here. The other thing, too, is sometimes build tools break. If you are the master of your build tools, you can go in and fix it. So that's always a good thing. Writing a build tool for Angular may give you also better standing to contribute to the open source community. Because you know how all the internals work, you can go in and maybe help out with CLI, maybe help out with some open source projects that are out there. There are some newfangled ways of building Angular, which I'll talk about later, that definitely need some help out there in the open source community. So just give you a brief overview about what we're going to do today. I'm going to give like a brief talk about how to get started. We're going to build out our own CLI so we can run command-line arguments that allow us to build Angular. We're going to copy files necessary for development as well as production. So for instance, we have a lot of library dependencies in our Angular project. We're going to copy those from node modules into the build folder. We're then going to figure out an easy way to work with an index.html since we're not using Webpack here today. We're going to learn how to call on the compiler CLI to build our application for development and production. Then we're going to learn how to optimize our code with Closure Compiler. And then I'll go back into a brief talk about next steps you could take with a build script like this, or writing your own build script, and we'll end with a brief Q&A. So getting started. Now, there were some prerequisites out there to developing today. You don't have to write code for this workshop if you don't want to, but there will be a couple code challenges where we are going to take like 5-10 minutes and write some code together. In order to build for Clojure compiler, you need to have the Java JDK installed. That's okay if you do not have it installed today. I do not suggest you try installing it right now. It is a 200 megabyte file that you are going to start downloading over the Wi-Fi, and I would not suggest that. So unless we want to break the internet, please, if you don't have it installed, that's okay. When we get to the Clojure step, you'll still learn the process of building with Clojure compiler. There's going to be lots of tips, and you'll be able to take that away and go home and install the Java JDK and run with it. If you want to code with the Node scripts we're going to be coding today, you'll need to have Node greater than 8 installed because we are using Async await for these scripts, and it is necessary to have a version of Node 8 installed for that. What? You could probably get away with 9. So getting started. If you haven't already, clone the repository. It is available at github.com/steveblue/custom-angular-build. I'll leave this up for a moment just to give everybody the chance to copy this, but it is also available here on the ng-conf page. There's a link to the GitHub repo. Wow, there's a party going on out there. Yes, believe me, we'll make some noise. All right. So after you've cloned the repository, it should be fairly quick. There's not many files inside of it. You should run npm install, or if you've got yarn, go for it, because why not? All right. Does anybody need the address to the repo still? Raise your hand. Okay. Give you one more moment. All right. So in this repository, there are 6 branches other than master. I just want to make everybody aware of this. You could run git branch, right, and see all the branches yourself. And if you fall behind at all during the workshop, just know that they're there. As I show introduction slides, it's going to have the branch name on the introduction slide, so you could check out to that branch. Just stash your changes if you have any changes before you do it, and be good to go. All right, so today, like I said, we're going to have some code challenges. There's 2 in here, but we're also going to do what I call a code along, where you can follow me as I write some code. We'll code it together, and I'll be talking some because I got the gift of the gab. So we're going to be writing some Node.js scripts today. An example of using Node for running commands like we would in the terminal is something like this, right? If we were going to do it in a very functional way. This is an example of calling on rollup and passing it a config. So we have this function, it's called run rollup. We pass it a config as an argument, and then we're going to use the exec method that's available in Node.js to execute the rollup command. This is very similar for when you're typing in the terminal rollup, -c, rollup config path, but our program is going to do it for us. Who here has experience with Node.js? Does anybody write a lot of Node scripts? All right, cool, about half the room. Well, that's okay. I'm going to take a very introductory stance with Node today, so even if you don't have much Node experience, hopefully we can get you up to speed. Why are we using Node? Well, it's JavaScript. We like JavaScript. We're Angular developers, so we can keep writing JavaScript. We can ensure that our build is going to be cross-platform using some of the tools that are available in Node.js. So it'll work in Windows as well as Mac OS, for instance. And it's already installed on all of our laptops, most likely. I mean, if you're coding Angular, then I hope you have Node installed. There's always this debate around build tools over time. You know, should there be a lot of code involved when you're writing a build, or should you be issuing a lot of configuration for your end user to use? So when the user is, when the engineer is using the CLI, will they be writing functions a lot of the time to use it, or will they be just configuring it, right? So an example of this that we're going to use today is using a configuration file. When we scaffold an Angular application with the CLI, it's going to spit out this configuration file. And I just want you to become somewhat familiar with it, where we're going to have this lib object that's going to list out all paths to all of our library dependencies. We're going to give the CLI an idea of where our source lives, where to build a project in a folder, where to distribute maybe a library package or something like that. But also you could mix in some code in here as well. So one of the things, if you write your own build, you can stick in some build hooks, right? So if there's a step of your build process you want to give end users of this access to, you could create an object like this, right? When the user is running a dev build, they have a pre and post hook that they could execute their own code, which is really ideal. So inside of our project, we're going to use this config. And this is just kind of some pseudocode here to give you an example. We're going to require the config file from our local project that we scaffold. And then we're going to, inside of our CLI, have a method that runs a task. And then we're either going to return a new promise or we're going to return exec, which is like I showed a few minutes ago, which is a Node command, which is asynchronous as well. It reacts kind of like a promise in Node. Inside of this method, we're going to do something with the config. We're going to execute a task, and then we're going to either resolve or reject that task. It's promises. Inside of the CLI repo, you'll find some key files. One of them is the package.json, which we'll work with very early on in this process. Another is the index.js file, which is an entry point for the CLI we're going to create today. And then we have a few other files in the build folder, which these are the scripts we are going to use to run a dev build, run a production build. And then any methods that are shared between those two builds, we're going to write in the build.index.js folder. And also we have a scaffold folder, which has some boilerplate code in there that will scaffold an Angular application for us. So if we take a quick look at that, what that looks like, here we have our package.json. You can see that we've given the name of our project NGS, right? Super NG. We have a few dependencies here. We've specified which engines of Node this is going to work with, but if somebody does have Node 9 installed, they could edit that little bit right at the bottom there. And then we have our index.js, which is an entry point for our CLI. I'm going to go in depth with this here in a few moments. And then in our build folder, we have an index.js. And inside of here, on the master branch or in the one/getting started branch, you will see a bunch of methods that have some logs here with some explosion emojis. These are placeholders until we actually code these portions of our build, just so you know when we actually see the log of our build going through all these steps that you haven't completed this part yet. Let's see, all right. So if we take a kind of macroscopic view of this whole landscape, we can see that there's some abstract notions we have to deal with here, right? We're going to have a template of some sort. This template is our index.html. We're going to probably have to deal with styling in some way. In this build, we're not going to pre-process Sass or anything like that. We're just going to have some CSS files to deal with. We're going to have to manage our library dependencies. We're going to have to deal with public assets in some regard. And we're going to have to compile our application because we're writing Angular in TypeScript, right? So we're going to have to compile that down for the browsers. And then we're going to have to bundle. Now, each one of these tasks that we have to complete in the microscopic view each task is an asynchronous process that is going to run, right? We're going to have to wait for something to happen, most likely, like when we're copying our library dependencies. We're going to have to wait for that to execute because file I/O takes a while, especially when you're copying node modules back and forth. We have some sort of configuration, and we can handle events if we want to. I'm not going to be really showing event emitter patterns here in Node.js today, but I will make you aware that they are there. We could write our build to be synchronous, right? Where we have these steps, where we process the template, we handle our lib, we ahead of time compile our application, and then we optimize. But this is not very optimal for a build. So if we do this synchronously, it's going to take a while, right? And an example of this it would be like this, right? We have this promise chain, right, where we have these utility functions, and we're going to format the index, and we're going to call then once that promise resolves. Then we're going to copy the library, copy public, so forth and so forth. And this just ends up being very synchronous, right? This would take a long time. Again, we could rewrite this promise chain in async await. Who here is familiar with async await? Who's used it yet? Oh, sweet, lots of people. So this is an example of just rewriting the promise chain here using async await. You are not going to get any performance benefit from using async await alone. It's just more human readable, right? We can see here clearly kind of what's going on versus the promise chain. Now, you could have a different opinion about that, but that's just my opinion, man. So, yeah, so this is an example of using async await to perform a build. But instead of doing everything synchronous, we can do things in parallel, which is super sweet because we can handle some of these really long tasks like copying over library files in one process. We can have another process that handles the template or copies our public folder over, which we're going to have. And then we can have another process that's running in parallel that ahead of time compiles the application. And then, since it has to optimize the application synchronously after it ahead of time compiles it, it does it in this lane. So an example of using async await to do this would be like this. Now, this is just one way to write a Node script to do this. It seemed to be one of the more simpler ways to kind of get the point across for this demo. But it is also a fairly performant way to do it. So we have these immediately evoked function expressions that call on async. And inside of them, we will await all of the methods that we are going to run today for our build. You can see an example of this inside of the build/dev.js file. All of this is boilerplated for you. We're not going to have to really touch this file at all. But you can see here that we're running the tasks in parallel. And we are going to await certain tasks that need to happen synchronously. So for instance, here in our build, or in our prod build, we have to wait for our application to ahead of time compile before we can optimize it with Clojure compiler. So tools in Node.js that we're going to use to do this is fs, which is a method that's, or a class, I guess you could say, in Node that is available, that has a lot of methods on it for file system I/O. We're going to use one method on it today. And And then we're going to use Path, which is another tool that is installed with Node.js. It's just there. We're going to use it to make all the paths that our Node script uses cross-platform compliant. And then we're going to use two other methods that are available in the child process module, which is also packaged with Node, called exec and spawn. Some open source projects we're going to use to make our commands even more cross-platform compliant. We're going to use this tool called shell.js, which is a wrapper around exec. It's going to allow us to run our shell commands for Windows and Mac OS. We're going to use this module called Commander to handle our CLI arguments. So when the user types in NGS build, Commander is going to process that and give us an object to work with within our code. It's much better than handling the process arguments by themselves. We're going to use this tool called FindUp, which allows you to work with files a certain way. It allows you to find a file in the folder structure that is above the directory you're in. It's a very useful tool because lots of times when writing build scripts like this, we may need to find like the root directory of our CLI that we're in or the root directory of our project. FindUp will allow us to do that because we have like a file in that root directory, right? Package.json, right? We can find it. We're going to use this other tool called HTML Processor, which is just an off-the-shelf module that allows us to process our index.html. So so we're going to build our own CLI today. This portion is just a code along where you can just follow along. I'll write some code and you can write it along with me. The CLI is an API layer for our build tooling. And it has an entry point, which is our index.js. Now, I don't want you to confuse this with the Angular CLI, right? We're writing our own today. Because who wants to write build tools without like a convenient way to use them, right? So in order for our Node script to be recognized as a process that we can run in the command line, we have to we have to write this line of code in the very first line of our index.js, which is our entry point of our Node application. So go ahead and do that. In index.js, the very first line, write this line. Now, if you've ever written a bash script before, this may look kind of familiar, right? It's kind of like bash scripting, but yeah. You can start from the master branch. That's perfectly fine. Yeah. This is going to establish for Node that this is a process that can run and that we can use it as a CLI. There's another step that we're going to implement here in the next slide that ensures that Node understands what our command is called. So in here, in index.js, I'm going to write pound bang usr/bin/node. Oh yeah, env node, yeah. My bad. What? No, this is the index.js that's in the root of the application, yeah. Blow it up. There it is right there. Okay, go ahead and save that file once you make that change. All right, we need to make one other change to our code here and to ensure that Node understands the command that we're running. In our package.json, we need to create an object that's called bin. And that object is going to take one argument, or not one property. called NGS. And we're going to tell Node that the entry point of our script is at index.js. So this is going to enable us to write in the terminal NGS and a command. Right? So this gives us an entry point for our CLI. So here in my package.json, I'm going to go ahead and create a bin object. I'm going to give it one property, which is NGS. And I'm going to point it at the index.js. And save the package.json. All right, now, in order for us to run this command anywhere on our file system, we need Node to recognize that it is global, right? And you'll see that maybe when you pull down open source projects and they say in their instructions to, if you want to develop this open source project, that you have to run this command npm link. What it does is it's going to treat our local installation of the package like it's global. Right? It's kind of like running an npm install with the G flag, but don't do that. Do not do that. We're going to run this command in the root directory of the repo. So here I have my terminal. I have the custom Angular build. If I run npm link here, it's going to tell me now that wherever my installation of Node is at this point in time, we're going to create it's a symbolic link, it looks like, and we're going to point it to the local installation of this package, where we are actually doing development on this CLI. All right, how's everybody feeling? Everybody following along? All right, cool. All right, so with Node, when we're talking about Node.js, we're talking about processes. Like when we run NGS, we're going to start up a Node process. And you can think of this process as a global object for Node.js that is kind of similar to when in the browser we have the window, right, which is a global object that we can use. In Node, we have process, right? And it tells us everything about the process we're going to execute. That is an external API that Node.js thinks we should know about that process. It is there. So when we run this process, just be aware that it is there. Right now, if we were to, in our index.js, console log the process, here, before Commander starts kicking in, we would be able to see it. And here in a moment, when we scaffold the Angular application, we can log the process and its object, and you'll be able to see it. Processes have 3 streams associated with them. They have an input that's called stdio. They have stdout, which is some output. A process will take in something as an input, like a command we give it in the terminal, and it will output something. It depends on the process, right? And then we have stderr, which is usually used for logging or to handle errors in some way. We're going to explore these as part of these processes that we're going to run today. All of them are streams. They also have this event emitter API attached to them where they'll fire off events every once in a while, like when the process starts, when the process stops, when there's data flowing through any one of these streams, they will fire off an event. Like I said, stdout. writes an output, and we can handle logs and errors with this other stream, std error. The process object has a property on it called argv, which lists the arguments in an array that the user types in the terminal. So when we run this command, we're going to use today NGS build dev with the watch flag. This is what process argv would print if we were to log it. Right? It's going to point to the version of Node which we're using that is executing this command. Then the actual process we are running, NGS, since it's installed, since it is linked globally, it will print like this. And then we have the command after the NGS command we ran, build, and then the argument for build, dev, and then another argument, which is -- watch. So this is a very useful object, but it's kind of cumbersome to keep working with this array. So that's why we have this tool called Commander, right? Commander, you can see here at the very last method on this program is to parse the process.argv. And what Commander is going to do is give us a more convenient object that we can reference so we can know what commands the user entered when they ran NGS build. You can see here we have one option in this example, build, and then the syntax for Commander to establish what that argument is, you can place between these square brackets. So we can see this here in index.js. Since this is the entry point of our application, we're going to put this logic here, where we tell Commander that our options should be build, right? So the user can type NGS build. We can tell Commander there's an option watch, and that watch should be equal to a Boolean, true or false. If watch exists, it's just going to be true. But we also have another option here that is boilerplated with this application called scaffold, which we're going to use in a moment. And then below that in this file, we can see we can begin working with this program object. We can tell that the user typed in NGS build because now the program object will have a build property on it. And if it exists, we're going to require the build script. If program.build exists, it will be equal to the environment that the user typed in. So if the user types in NGS build dev, it will be equal to the string dev, or if they type NGS build prod, it will be equal to the string prod. So we're going to dynamically require a build script based on that input. Then we're going to create a new build and then run init on that build. The first command, though, we're going to run with this CLI is to scaffold a new Angular application. And we're going to require a different script for that. We're again going to instantiate it and then call init. So the process today for coding during this workshop is kind of like this. We're going to write most of our code, if not all of it, in the repository that you all pulled down. But we're going to scaffold an Angular application in another folder. It can be a sibling to the folder that is this repository that we're working with right now, but it can't be inside of it. Otherwise, our scripts are going to get really confused right now. And then we're going to have an express server that runs so we can see after we run the ahead of time compiler, we can see an output in the browser. We can see an Angular application running. And then when we optimize our application with Clojure compiler, we'll be able to see the output of the bundle and its size using the express server. So in order to scaffold an Angular application with this CLI, what you should do is you should create a new folder somewhere else. Like I said, it can be a sibling to the repository. You're going to make a new directory. You can call it whatever you want. I chose my app. Change directory into that application, and then run ng-s scaffold. And then once you are done with that, run npm install, or if you have yarn, go for it. Did you run npm link before? Hmm. 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 Is anybody else successful with this command? Yeah. Okay. It's making me a little nervous there for a second. There may be, sometimes this can fail if Node is not aliased correctly in your path. That could be a problem. That's something that I see pretty standard. Like if Node was installed using the download from the website, that could cause a problem. You can try unlinking and linking again. That might help. So you can run npm unlink and then npm link, and it could work. Who's installing the Angular dependencies now in their application? All right, cool.
I forgot to take off that requirement for the node.
What do you mean?
For being less than 9.
Oh, okay, yeah. Yeah, that could be another issue too. If you have Node 9 installed, this will work with Node 9. I don't see any reason why it shouldn't. All right, so our Angular project looks like this. We have a template, which is our index.html. It's in the src/public folder. We have an src folder that has all of our Angular source inside of an application folder. We have some global styling that's available in the style folder. Once you run npm install, of course, we're going to have a node modules folder that we're going to deal with. We have some tsconfig hanging out. Inside the src/public folder, we have some system.js config that we are going to copy over to our build folder once we build. We have a closure conf, which we're going to go over here in a bit. That's going to configure closure compiler. And we have a server.js, which is our Express server that's going to allow us to host this Angular application locally. So you could, right now, run node server inside of your app folder. And you're not going to get much because we haven't built anything. But if you were to run node server, you will see that Express is available at localhost :4200. But if you were to look at that in the browser, you won't get anything yet. Oh, well, crap. There we go. I spoiled it for you. Let me remove my build folder. And try again. There we go. That's what I was looking for. So you'll see something like this in the browser because we don't even have a build folder yet. We haven't built anything. And this is good. It's good that we see this error right now. Because if you saw a build, I would be mystified. Unless you jumped ahead or something, because you can do that. This server also comes with live reload baked in for our development build. If the user runs ng build dev, it's going to have a script in the index.html that loads live reload. And so in order for you to actually use live reload, though, you're going to have to use the watch argument here with node server. So the three commands we're going to develop out today are ng build dev, ng build dev with the watch flag, which is going to use put the ahead of time compiler in watch mode. And then we're going to use this prod command to build our application for production using Clojure compiler. Now, at any time in developing this stuff, you could stop the process with Command C. I'm going to flip back a few slides just because there's a couple here. Sometimes when you're building out these applications, if you do not stop your node script appropriately, it will just keep running in the background. This can happen a lot during development of node scripts. So if you're on Mac OS or you have like a Unix file system, you can run this command ps aux and then grep node, and you can list all of the node processes that are running. On Windows, you can use task list to do the same thing. And then with a Unix-based system, you can use the kill command very judiciously with the 9 argument and the process ID of that node command that's still running when it shouldn't be. On Windows, you can do the similar thing with task kill. I would not try to kill all the node processes at once. I was actually looking at a blog post the other day, and somebody said to do this. That's probably a very bad idea. VS Code is running a bunch of node processes right now, and if you do that, you will hose VS Code. Or you may have Slack installed or some of these other applications that are running that have node processes running. Don't kill them all at once, please. All right, so let me catch up. All right, so, oh, I'm going the wrong way. So we're going to get to the next part of our workshop where we're handling files. All right. So we started up our build, and we started up our server. We didn't run a build command yet. And we noticed nothing was there, right? Because we haven't copied any files from our source to our build folder. So in order to do this, let's take a step back and just learn some common things that we may need to work with when writing these kinds of scripts. There may be times where you need to know the file name of something you're working with. You may need to get rid of the rest of the path and just know the file name. You might need to figure out what the base path is of somewhere that you're working with. For instance, we have this CLI project, and its base path would be its root, right? Or you might need to know the base path of a string that is a very long path. You may not, and cut off the file name. You may need to figure out what your project root is, like the Angular project's root. You may need to know what the CLI root is. You may need to figure out what the root is for the process that the user is trying to do right now, right? This could be a different thing, right? So you might expect the process root to be the same as the project root, but we may not always be running NGS at the root folder of our project, right? We may run NGS somewhere in another directory. Say we're in a component directory somewhere in our Angular project. We could code our CLI so that it takes that into account and then finds the process root, or from the process root finds the project root, right? You might need to know the directory of something that's executing right now. But the problems that we're going to solve today are how do I copy from the source folder to the dist folder, and how do I make it cross-platform? And the tools we're going to use to do that are path, fs, and findup. So fs allows you to work with the file system. there's a lot of awesome methods on FS, like reading files, writing files. We're not going to use them today. We're going to use this one, fs.existsync. And what this does is allows you to figure out if a file exists somewhere. You pass in a path to existsync, and it will return truthy or falsy if it exists. We're going to use path. So here's an example of it where we can require path. And then we can use methods on path to print, if we were to console log like path.join or path.normalize here, it would generate these two strings down here at the bottom of this slide. It's a way for us to handle paths cross-platform. Because if we're writing these scripts and we're always using forward slashes, because we're used to our Unix file system on a Mac, that is not so good for Windows users, right? So who have to use a different way of writing file paths, right? So these two methods, join and normalize, do the same thing. They're just two different ways of doing it. You can use the method you prefer. I kind of like join more than normalize, but sometimes you can use one or the other when it suits the problem. So node module, if you use path.join and you pass in node modules, comma, Angular, comma, core, that's going to write node modules slash Angular slash core. The process object has a few methods on it as well that we can use. Process.cwd will return the current working directory that we're in. There's another global namespace property here called dirname that will give us the directory of the current executing script. So for index.js, like we've been working with so far, if we were to use --dirname there and we were to log it, it would print the path to that index.js because it is somewhere in the file system. And people are going to install the CLI all different places. So now that we're using dirname, we can make this dynamic, right? Rather than forcing our users to install it in a specific location on their computer. Path.dirname should not be confused with __dirname. Path.dirname will return the current directory name of a path that we are working with right now, like a string that is a path. Path.base name will return the last portion of the path. We can get a file name this way. We can get the last directory of a path using this method. And like I said earlier, we're going to use findup. And we can use the sync method on findup to find a file somewhere in the file system. What findup's going to do is it's going to travel up the file system until it finds the file, and then it's going to return an absolute path to that file. Absolute paths to these files can be your friend. Because relative paths, depending on the user's file system, can do some wonky things sometimes. So if we're able to dynamically generate an absolute path to something, I think that's somewhat ideal. So the sync method is a blocking function, though. And you can see these being used in build/index.js. So if we look at that file, we are now done with index.js. The root of our directory, of our project. This file now is what we're going to start working with. Since we've linked our CLI, there's not much we're going to do in the terminal now with the CLI. We are now going to be running commands within the Angular project that we scaffolded. But we're going to be coding our build here. You can see that at the very top of this file, we're requiring all the dependencies for this build script. And shell, path, file system are listed, findup. And on line 8, you can see a method for finding the process root. Again, the path the user has typed in the command. This is a very handy thing. You find that using path.join. We're going to use some fancy, some uses of path here to absolutely determine that this is the directory the process is running in. Then once we have the process root, we can figure out what the project root is. Even if the process is running in the same directory as the project root, FindUp will start in the directory you specify, and then it will travel up the tree. So on line 9, you can see we're calling findup.sync, and we're looking for this ng-config.js file inside of our Angular project. So the next one is CLI root. We're going to use findup again, but this time we're going to use the __ dir name because we're going to start in the file system where this index.js file lives, and we're going to travel up the file structure until we find a package.json, because our CLI has one right here. We now know what our CLI root is. And then we are going to create a const called config, and we're going to require the config from ngs.config.js. So then we can see we have a class here called build. It has a constructor, and we're going to put all of these properties on here so that they can be used in our development build and our production build. Again, the development build extends build, right? So does the production build. The class build here is going to be where we code all of the methods that are shared between the development build and the production build. All right. So I already talked about absolute paths, but I mean, this is an example of it. So findup is going to return an absolute path, and it looks something like this. So on Windows, it's going to look like the bottom path because it's absolute. And in Unix, it's going to look like the top path. All right. So right now, if we were to run NGS build dev in our Angular project, we should see that it's trying to copy the public folder, that it's trying to copy the library dependencies, format the template, and compile the source. Let me demo that real quick. So here, so I have my Node server running in one tab. I'm going to run these commands in another tab so my server can stay running. So if I run NGS build dev right now, we'll see something like this logged in the terminal, where inside of our scripts, we already have a lot of these console logs hanging out, and it's going to log all of the library dependencies that we're trying to copy. It's going to log that we're trying to copy the public folder. It's going to tell us that NGC started, even though we haven't really started anything yet. And it's going to tell us that it's trying to format a template. But it's got all these emojis here that are exploding. So that's a problem. We should probably take care of it. So as we resolve these steps, here in our source, you're going to take away the console log or put it somewhere else, and you can just get rid of the bang, right, once we start coding this. So it'll look like it isn't breaking. So we're going to start off by copying our public folder. We have this src/public folder, which has our index.html in it. It has some assets that are required by our application. It has all our CSS in it. It has some system configs. We could run this command in the terminal, cp, which is copy, and then we're going to use the R flag to copy recursively every folder that's inside of the public folder. But we can use star at the end of the path that we want to copy the contents of that directory and not the directory itself. And then we can tell the copy command, we want to copy all the contents of the public folder to the build folder. The default behavior of copy would be to copy the public folder to the build folder. So you would have build/public, but that's not what we want. We want all of our public files to be at the root of our build. This is not cross-platform though. If you were to try to run this in Windows, it would silently fail, which is always fun. It looks like it's running, but it isn't. Windows doesn't know what to do with the star. And actually, this operation is kind of complex in the Windows bash. I'm not going to review it today because we have tools that make this easier. In Node, instead of typing this command into the terminal manually, we're going to have Node execute the command. We're going to require the require the child process module and the exec method that is available in this module. And then we're going to have some method in our application that looks kind of like this, where we have a method called copydir, and we're going to return exec, and it's going to run this command. We can pass in options as a second argument, and then exec has a callback that gives us access to the 3 streams that I outlined earlier. Well, actually 2 streams that I outlined earlier, stdout and stderr. So exec will create a shell for us, like we were writing a command in our shell in the terminal. It buffers the output, and it resolves like a promise when complete. And it happens to work with async await in Node. So we could do something like this to try to make it cross-platform. Instead, here, let's go back and forth so you can kind of see the difference. So we had the string here, right, which has our paths to src/public/star. We could try to do this where we use path to normalize the paths for Windows. So when we're calling CP, when we're using CP in the Windows PowerShell, for instance, it will normalize the path for Windows. But this still doesn't work because Windows doesn't know anything about the star. So we have to do something like this, where we're going to use this other package called shell.js. And what shell is a wrapper around exec, and it'll handle all this cross-platform stuff for us. It's a wonderful tool. So our method becomes something like this. Let me back up one thing. Where we're going to check if a file exists. So if our dist folder doesn't exist, because we are copying a directory from 2 arguments, source to dist. If the dist does not exist, we're going to use shell to execute the makedir command with the p flag to create that dist folder. Now what the p flag does is it will create all subdirectories in that path leading up to that directory. It's very convenient. Then we're going to use shell.cp with the R flag to run our copy command. This time we're still normalizing the path, right, for Windows and Unix. So this should work in both. But shell is going to make it cross-platform. It's going to make the star work in Windows. So if you go into your project, here, and we take the console log, and I'm going to sandwich it here in between these two snippets of code, where you can uncomment out the code that's in the copy dir method, and we get something like this, right? Where we check to see if a file exists. We're going to use shell to make that directory if it doesn't exist. We're going to log for the user of our CLI something is happening. All right, I'm going to take the bang out. And then we're going to return shell.cp. Much like we can return exec in these methods, like I said, shell is just a wrapper. It's going to resolve like a promise. So in our dev build, we have this await, right? It's calls on copy dir. And we're passing in our src public folder and the build folder as arguments. Now these arguments are using properties on the ngs.config file that's in the root of your Angular project, right? Because we required that in the first step. So we can make this even more dynamic and configurable. So if we try to run our build now, we get something like this, right? Wah, wah, wah. We didn't really do much, right? Because all we're doing is copying the public folder so far. But we see that the bang came out of it. And if I were to ls the build folder, we can see that we have all the files from our public folder. If we were to try to start up our browser again, we should see something like this, which is a loading icon that tells us our Angular application is not built yet. We're still waiting for that to happen. All right, now to copy our library files, we have to do a slightly different thing. We shouldn't just copy the entire contents of our node modules folder to a library folder that inside of the build folder our Express server can reference our libraries from. That would just be bad news bears, because it's going to take forever to copy all the node modules. We only want to pick out the node modules that we want, and even from those packages, the files that we want to use to make sure that this is fast for our build. So we're going to take all of our library dependencies that we get from the array in ngs config.js. You can see that they're being logged here like it's trying to copy them. We're going to copy them from the node modules folder to the a folder inside of our build called lib. Now this array of paths is configured in ngs.config, and inside of our build, our ngs config is a property on the build called config. So its properties are again usable. So we can use the lib property and for the specific environment that we are trying to build. So if we back up to the dev build, you can see here we are awaiting this method called copy batch, and we're passing in the array of library dependencies from our config, and we are passing in a second argument that should copy those dependencies to the dist. And I had set up a little code challenge for this, but you know what? We're not going to do it. Just for interest of time, because I think we should focus on the ahead of time compiler and closure compiler. So go ahead and inside of your CLI, if you have any changes, just stash them like that. And you can use git.checkout to check out to /template, which is the next step in our process, just like so. And when you do that, you should see in your build/index.js file the solution for this code challenge. So in our dev build, we are calling copy batch. Copy batch is going to return an array of promises using promise.all. Since we are inputting an array of strings, when we call promise.all, we're going to map that array of strings using this copy_to method we have that is just above, which is going to return promises, right? So we're mapping our strings to promises. In copy_to, we're going to return a new promise. We're checking to see if the out file exists. The out file is created by joining the path of the dist folder to the file path of the node module file that we are trying to copy. And if it does not exist, we're going to do a similar operation we did for the public. We're going to check, okay, does the path that we want to copy to exist? Does the directory exist? If it doesn't, we're going to create that directory using makedir. Then we're going to log that we're copying the file path. And then we're going to actually copy the file path from the node modules folder to the out file. So when you run NGS build dev now, you get something like this, right? Where it's logging that we copied each one of our library dependencies, and that we copied our public, and even that it formatted our template, because we are skipping ahead for time. So let's go back to the slides. Again, our NGS config looks something like this. We have our library files. In the next step, we're going to take the index.html and we're going to copy it over as well. Since we are already on this branch of the Git repo, it's already happening for you. Again, I don't want you all to concentrate on this because the meat of this is ahead of time compiling, closure. So we're going to use this HTML processor module. It's been around for a while. It's what Gulp and Grunt use to format index.htmls. It takes environment variables. So we can do something like this, where we can comment an index.html, and we can comment it with the build, and we can run a command that we want to remove a particular snippet for a particular build inside of our index.js. It's pretty handy for this. It allows us to have one index.html for multiple environments. It's just a way of doing this. Again, Webpack, it does a lot of magic with indexes, right? So we don't have Webpack today. So this is just a way for us to handle our index.html. Now our development build is going to require the reflect metadata package for Angular. It has a live reload server. It also has this file called system config. We're using system.js because it's already a dependency for Angular, so we might as well use it. System.js is going to load UMD modules for our development build. The system config looks something like this. Again, this is in the src public folder. You can take a look at it in your Angular project. We established a paths object that allows us to create these aliases for node modules and for lib. All the files that we copied from our node modules we copy them into the library folder or lib folder. So this alias is going to allow us to map the requests that the browser is making for these dependencies like Angular HTTP or Angular Router or Angular Forms. We can map that request to the common JS bundle for each one of these dependencies. So we can develop with these modules. You would do a similar thing for RxJS, and TSLib is necessary for, I think, the HTTP client. This process runs something like this. Since HTML processor is installed locally and not globally, we have to run the process locally. So we can't just type in HTML processor in the terminal, right? We would have to type in node_modules/.bin/HTML processor to run this process locally. HTML processor takes a few arguments. The first argument is the index, or is the template we want to process through HTML processor. It takes an output argument, -o, which tells us where we want HTML processor to put the index.html once it's sorted through all the environment variables. And then we pass it an environment. So this would look something like this in Node.js, where we call exec. And exec will look for HTML processor locally, and then pass in the index.html as its first argument, use the output argument and the environment argument. But that is not cross-platform. So the HTML processor tool is not cross-platform by default. Not all node modules are. So you have to do something like this, where you use path again to join the path to HTML processor. So on Windows, we'll get our forward or backslashes or forward slashes, whatever they are. Then we're going to call exec with that command. We're going to pass it the template because we're making this dynamic. Then we're going to, with the output argument, again, we're going to use path.join to put in a path that's Windows and macOS friendly. And then we're going to use the environment variable that's available on the program object. Now, if you remember the program object from the very first part of this, that was commander, right? Where it's processing our process.argv. We now have the env, when the user typed ng-s build dev. The string dev will get placed right here. So we get something like this, where we have our method format index, and we return exec. So if we look at our code, it looks something like this, right? This is an example. So we're returning exec. We're joining the path from our project root, right? And we're using path.normalize here. This is a little different than path.join, but it would do the same thing. All right. So if you ran ng-s build dev now, you might see something like this, right? We no longer see the complete log of all of our library files. That's because in the previous step, we checked to see if that library file existed in the build folder, and if it exists, it's not going to try to copy it again. This is a performance improvement for our build, so it can run super fast. So if you were to remove the build, you get something like this again, right? Where it's going to copy all of the library dependencies again. All right. So you're not going to get away from this so easy. We actually will have a code challenge this time for the ahead of time compiler. Now that we have an index.html that's being properly formatted, we have all of our library dependencies in place, we can compile our Angular application. We're going to rely on this package, the compiler CLI. The CLI for the ahead of time compiler looks something like this. We can use the ngc command, not to be confused with our CLI ngs, with the p flag, and we can point ngc to a tsconfig. ngc is just a wrapper around TypeScript, and the p argument will point us to a tsconfig. Notice how it's the tsconfig.dev.json. Our project does have a tsconfig.json at its root. This is a best practice, most likely, because VS Code is going to require a tsconfig there, so it doesn't get all hung up about emitting decorator metadata and experimental decorators. We configure ngc to have a module resolution of node, so it looks in our node modules. And we configure ngc so that we point it to some type definitions that are available via the @types library. We're going to enable our ngc to know that there are node types and that there are 2 lib packages for ES2017 and DOM. This is pretty standard. The Angular CLI would spit out something like this as well. So we have this tsconfig.dev.json, which extends tsconfig.json for our development build. We're extending it because our development build is going to output the ahead of time compiled Angular application in the build directory for development. It's going to target ES5, and it's going to compile everything with a CommonJS module pattern because we're already using a CommonJS module pattern for all of our library dependencies. This will allow us to run a development server. This is different than production, though. With production, we're going to do something slightly different. We're going to include all of the TypeScript files inside of our source and this file, main.dev.ts. Main.dev.ts, sorry, that's a little typo, I shouldn't say JS, looks something like this. We're going to import platform browser from Angular platform browser. We're going to import app module ng-factory from our source after it's compiled as an ng-factory. And we're going to call bootstrap module factory on platform browser and pass in the app module ng-factory. With the ahead of time compiler, we get a watch argument, something like this, which would start up a watcher. It allows us to run ngc a little faster because it puts all of our application code in memory. It will compile on change of all of our TypeScript, HTML, CSS inside of our Angular application. So we could do something like this, right, where we use the exec command to point to ngc installed locally. We use the p flag. We are going to use this argument, this option called silent to silence the shell. This would give us the advantage of being able to style our own logs if we wanted to. We could then use the callback here so that whenever ngc is logging, we can check if std error is being passed through the callback here, and we could log it. The problem is, in watch mode, exec is not going to be something we want to use. Exec returns a buffer. It expects the process to stop, whereas with the watcher, we want to keep it running. So we're going to use spawn instead. We're going to point spawn towards ngc, but spawn, unlike exec, lacks a shell. So with exec, we could have just passed in the command like we would in the terminal. But with shell, we can't do that. Or sorry, with spawn, we can't do that. spawn, we have to pass in the arguments, like so, for our command we want to run in an array as the second argument. And then we're going to give spawn an option of inheriting stdio, which allows spawn to inherit the standard IO of its parent. Its parent is our index.js, right? Is our process that is running right now. Spawn is a child of that. This is Node. That's why it's called Node. You can have all these nodes that are children of things. So it's going to inherit the standard IO so that when, So the challenge for you is to use exec and spawn. Inside of the project here, we have a compile method that is resolving a promise. I want you to take 15 minutes, we have time for. What this method should do is compile your Angular source for dev in watch mode. You should use the environment variable that is available in this class. Write your solution in compile. Use spawn and exec. And then look for the output in build/src. You can preview the output in the localhost :4200 as well, because you have a server running. You have an example of how to use exec here in format index. Here, I'll get you started. So if we wanted to run without the watcher, we would do something like this. We would return exec. And then we're going to use path.join. And path.join would be the node modules .bin, and then ngc. So this will run the ngc command. But we want to point ngc to our tsconfig. So we can concatenate a string here, because path.join is just going to create a string. So you can add, making sure there's a space between the path, the p flag, and then, again, we're going to use our environment variables. So we want to point it to the tsconfig dot, and then program.build, or this .program.build, sorry. And add .json at the end. So this will build us for a build, this will ahead of time compile our application for whatever build we're in. So if the user types in NGS build dev, it will compile for dev. It will use the tsconfig for dev. If they run NGS build dev watch, that won't work quite yet because we need to explore that. But if they were to run NGS build prod, it would just pick up the prod JSON. So if I go in here, NGS build dev, all right, I didn't put any logs, so it's going to complete. And if I refresh my browser, we can see we get a little Angular logo here now. That means our Angular application is now compiled. Now, we don't have any feedback for the user, so that's using our CLI. So I'm going to go ahead and log before exec runs that ngc is started to prompt the user that something is happening. We expect a script to run. But ngc by itself is not printing anything in the terminal. So we can go in here, and we can pass it an options as a second argument. And then as a third argument, we get a callback, which would be 3 arguments in here: error, std out, and std error. And we can, in here, log std error. So now that when I run NGS build dev, we can see that it shows us that NGC started, but it still doesn't tell us that it completed. That's because NGC doesn't emit anything from std error when it runs in this mode. When it runs just as the exec command. So if we wanted to print that it finished, we would have to wrap this a different way. So what I want you to do is take about 5 minutes and figure out how, using this pattern, the user could run the watcher. And if I ran NGS build dev watch, we have to use spawn instead. And like I said, spawn is formatted like this. So go ahead and try to figure out in the code if the user ran the watch command, watch argument, use spawn instead of exec. I'll give you a little hint. It should probably look like something like this. Where we're checking if the user ran the dev build, and if the watch argument exists, we're going to call spawn instead. And ngc is going to know the user used typed or -- watch from our CLI, so we have to tell ngc to use watch so it can run its own watcher. Give you 2 more minutes. If you're on Windows, I would highly suggest you use path.join. for the node modules /bin/ngc. All right, so let's go ahead and look at the solution. It's okay if you are not quite done, but we need to move along because we have limited time. So I'm going to go ahead and stash my changes, and I'm going to check out 6/closure. So we can jump ahead. Kind of, well, it doesn't look like VS Code agrees with me that I changed. All right, there we go. So this is an example of a full-on implementation of this, accounting for all cross-platform stuff we need to do. So if the user is in the dev build and they use the watch argument, we're going to spawn, and we don't have to create a variable here. We could just spawn. And to make this compatible with Windows, we're going to use path.join to create the path for ngc. Then we're going to tell ngc to find the tsconfig for our build. And then once we do that, it's going to, inside of our Angular application, it's going to start ngc. But you see here now we get this little log, compilation complete. Now ngc didn't tell us that it was done. Be nice if it did, but it doesn't. So what I had to do to make this work was if the user just wanted to run the build without the watcher, I call an exec. But here we're going to log the any errors that would happen from our Angular source. If there is no std error, we're going to have a little else here that says the compilation is complete. And it's just and then we're going to resolve the outer promise here. The reason why we have to use a promise like this is because of this little part here. We could just return exec. It acts like a promise, but because the ahead of time compiler doesn't tell us that it's complete, I thought it would be nice to have a little log here to tell us it was complete. All right. So when we run, oh, yeah.
If there is an error, do you want to reject any errors that really happen?
Yes, you could. You could do something like this, right, where you reject. The reason I didn't do that here in this presentation is because in Node 8 and above, it's very strict about rejections. And if we included reject here and didn't really do anything with it, it would complain at us. I didn't want it to mess up the demo. But yeah, you could do something like that. Yeah. That's what we're doing. So our Node script is running it like we would in the terminal. When I typed in the terminal, I ran NGS build dev watch, not NGR. Right? NGS is our CLI, right? So yes. Yes. Yeah. So our Node script is executing that NGC for us. So we don't have to type it into the terminal ourselves. Oh, you could do that. Yes, you could very well take the source, right, and start using it. But then we're using private methods in there that could change, could mess up our build if they do change over time. I chose just to use this pattern, right? Just because we're using the external API that doesn't change, right? So, yeah. All right, so let's go ahead to Clojure compiler because we're running out of time. So the main differences between our development build and our prod builds are in prod, we only need zone and system. We don't need reflect metadata. And system is going to load our bundle and not the UMD modules it was loading in dev. Our dev build uses a tsconfig that compiles our source into the build folder. And then it uses main.dev.ts as an entry point. But our prod build is going to output all of our ahead of time compiled code into a staging area that we're going to call ng-factory. It's an ng-factory folder. So Clojure compiler can get in there and use that as a source for optimizing and bundling, right? Because we don't want to spit out all of our ahead of time compiled code into the build folder, otherwise that could get deployed. We don't want that, we just want to deploy our bundle. So the main JS looks like this. The only difference between it and develop is we are now importing enable prod mode and calling it. Because we are ahead of time compiling both development and production. In our index.html, we just need this script tag for system.import.js. This is what it does. It's going to import a config for prod, and then it's going to, once that config is loaded, it's going to then import the bundle. And all this is boilerplated for you. In system.config.prod, we have something like this. If you remember from our development build, our config was very long. We had to configure it to map all these requests to the common JS bundles. We no longer need to do that. We just need to tell system.js where our bundle is. So when we make a request for bundle, it knows it's in bundle.js. NGC is going to use the tsconfig.prod, which extends tsconfig. It has an out directory of ng-factory instead. Instead of targeting ES5 and CommonJS modules, we're now targeting ES 2015 modules. And we are using the ES 2015 module pattern. Clojure compiler is good at both. Clojure compiler is a project that started about 10 years ago. And it started at evaluating ES5 and below. Over the past couple of years, it's gotten better at evaluating ES 2015 modules. So we're going to output ES 2015 modules for Clojure compiler. So our prod build becomes something like this, where we're going to copy our main.ts to main.js. So Clojure compiler can use it as an entry point for the bundle. Clojure compiler cannot interpret TypeScript. It can only interpret JavaScript. We're going to run the compile method again, like we did for develop, but this time we're going to run the bundle method. Clojure compiler is an open source Java application. It requires the Java JRE. Who here has that installed? Well, some of you do. Okay. So if you do not have that installed, you're not going to be able to see the magic that happens here. But I will demo it for you. It has a RESTful API, which we're not going to use today, but it's really awesome that it does for when you're using CI. It is an optimization tool, first and foremost. It is really great at optimizing JavaScript. It is probably the best tool I've seen. I do not work at Google, okay? I am a third party saying this. It is a wonderful, it will optimize your bundle better than Uglify can. Clojure compiler does this using type annotations in a very Clojure way. But we don't type annotate our code base using Clojure. We type annotate our code base using TypeScript. So the Angular team about a year ago came up with this tool called Sickle that will convert all of our TypeScript annotations to Clojure annotations for us, which is really awesome. It does this when we run ngc with some compiler options. Clojure compiler is really awesome at providing warnings. It can warn us of security holes in our application, warn us of duplicate code, all sorts of things. You implement it like this. If we were to type it into the terminal, this would be the command that we run. Since this is a Java application, it relies on a jar file. We're going to run Java, and we're going to point it to the jar file, which is in the node module / Google Closure Compiler folder. There's a compiler.jar in there. We're going to tell Closure Compiler to use the closure.conf file that is in the root of our Angular project, and we're going to tell Closure Compiler to output a bundle.js for us. The flag file looks something like this. This is closure.conf. This is the header for it. We have to tell Closure Compiler which compilation level to optimize our code at. It has various optimization levels where you can somewhat mangle things. You can mangle it really heavy. Advanced optimization is it does the most mangling, and it will optimize your code base dramatically. I don't think it's worth going to Closure Compiler unless you want to take advantage of advanced optimizations, because it's the mode that will give you the most optimal bundle. We're going to tell Closure Compiler to transpile our ES 2015 code to ES5, create a source map, and give it a module resolution of node, so it knows that all of our dependencies are in the node modules folder. Closure will try to mangle everything in your application source, which is not necessarily something you want to happen all the time, especially if you are relying on external libraries. Closure is not the most compatible thing with a lot of libraries. So we have this opportunity to make a library external to our application so that it will not be compiled with the bundle. There is a file called closure.externs in the root of your Angular project for this purpose. Closure Compiler will not try to bundle anything that's declared here, and it won't mangle any of the references to methods you're using on that library. A default externs configuration would look something like this, where system is external to our application. If you're using Angular animations, hammer is. There's a couple other methods in the Angular source that should be treated as external to our source, to our application source, that are listed here. We also need to tell Closure Compiler about all the JavaScript to put in the bundle. And so we will tell Closure Compiler about all of our library dependencies that it can bundle like this. We can specify that with a JS flag and point it to the node modules folder and that library. So with RxJS, for instance, we're going to tell Closure Compiler to use the ESM 2015 modules in RxJS and try to bundle using those. We're going to give it access to all of the Angular dependencies that we need for our application as well. And then we're going to specify that we want to use package JSON entry names for ES 2015. So this coincides with the package format that you might be familiar with that was announced last year, where in Angular libraries, you would see a main field in the package.json that would point to common JS modules. But you would also see an ES 2015 field pointing to FESM, or ESM modules. And so we need to tell Closure Compiler to use this property in the package.json of the library that we're pulling in so that it knows where to pull the library code for our bundle. So we also need to tell Closure Compiler about all of our source, which is being held in the ng-factory folder, and about our entry point for our application, which is our main.js. So when we do this with Node, it looks something like this, where we're going to call Java, and we're going to make it happen. All right, so let's see it in action. When we run ngs build prod, it's going to tell us ngc started, Closure Compiler started, and Come on, Clojure. When I give demos, it takes a while. All right, and it's finished. All right, so once it's finished, if our server is still running, we can see, hold on, let me do one thing. We need to remove our build folder. Let's do that. So we have a very clean production build. Because right now, the way this build script is written, it's not going to try to delete anything in the build folder, so we should manually try to remove it before running the prod build. So once we do that, we can see a fairly dramatic improvement in the load time of our application. And here, if we look at the network requests, we can see that there are very few network requests happening versus very many in our development build. And if we look at the bundle.js right now, we are at 60.9 KB. All right, so that may seem a little big for something that should be a really excellent optimization tool. But this Angular application is using the router. It's using the common module. It's using, the more modules you use, the larger your bundle is going to become. There are ways of getting this bundle size down even greater, though. So, some Clojure tips. Always use advanced optimizations. In order to support Clojure compiler for your Angular application, you need to type all the things, like everything. All right, you cannot get away with having any as a type. Clojure will not like that. It does matter how you structure your code for tree shaking. That goes with any tool, not just Clojure. So if you expect a really optimal bundle, you need to make sure your application source can be tree shakeable. Just remember that externs won't be mangled. So when and Clojure it can't mangle strings. So if you use bracket syntax for referencing properties and methods on an external library, that's going to go a long way because Clojure, if you're using dot syntax, it may try to mangle part of that. Clojure compiler cannot support import star from something yet with ES 2015 modules, which is kind of a bummer. And it is a feature that will come to Clojure compiler soon. But you can get around this using another tool called rollup. Right? If you have a library that is distributed with ES 2015 modules, you can use rollup to roll up that dependency as a FESM, right? As a flat ES 2015 module, so that all of the source is there in one file, and Clojure really likes that. Clojure will optimize the hell out of that code. All right. So, like I said, we could get even smaller at this point in time right now. RxJS is not distributed as FESM. It's distributed as ES 2015 modules with RxJS 6. So if we were to roll up RxJS as FESM, which is possible prior to our build, Clojure compiler will be able to optimize it even greater. In my tests, it brought the bundle size down by 10 KB just doing this step. We can also, on our server, use Brotli compression instead of gzip compression, right? So Brotli is going to bring the bundle size down even more. So we'll go from something, what is it right now? 60, oh, sorry, I clicked right there. It's 60.9. I think with this application, it brought it down to about 48 kilobytes, or 50. So you can squeeze more and more out of it. All right, so what can you do next? So what we did so far is we created a dev environment. We optimized our bundle for production with Clojure compiler. Ways to improve this build: we can style our logs. Right now, our logs are very monochrome. It'd be nice if there was like some very user-friendly logging that can happen. We have a way of processing. We need a way of processing or pre-processing SAS or LESS or something like that. We can build that into the build. We can give the end user some build hooks. We can give the end user a way to deploy the project after the build is done. We can also integrate it with a bunch of other tooling. Other builds we could create with Clojure compiler specifically, you can lazy load with Clojure compiler. It is, Clojure compiler itself will not code split the application for you. you need to write a script that uses the output of Clojure compiler to code split your application. If anybody wants to know how to do this, I am available later today in the Tour of Heroes room. I can show you how I did it. It is possible, though, and you can get really highly optimized lazy loaded modules out of Clojure compiler. We can server-side render. We can create a build that allows us to use Angular Universal. We could build an I18N to this build. We could write a build that creates a package that is the library package format. That's fine too. We have ng-packager for that too. So we could also write a build that allows us to distribute our code natively. What's next? Well, you could write your own build. You could extend this build. You could learn Bazel, because now you know all the prerequisites going into that. Bazel is a wonderful tool for optimizing your dev experience, especially when your application scales. I've been evaluating it at work, and it is really great. But if you don't really know the steps going into it, it can be really hard to configure. So now that you know how the ngc compiler works, you can begin to get in there and start configuring Bazel. But really, evaluate what works best for you and your team. You don't have to use this build per se. This is a very opinionated approach of doing things. You can evaluate what works for you best and run with that. I maintain a project called Angular Rollup. I've been doing it now for over 2 years, I think. It handles all this stuff, right? So, I mean, you can lazy load your application with it. You can even have this build for dynamic routing where you can configure the router before the application compiles. And then you can run it in Universal, I18N, all that kind of sort of stuff. 2.0 is coming out very soon. It's got like prettified logs, integrates with the Angular CLI a little better, stuff like that. So that's it. I think we're out of time. So, all right. Well, yeah, thank you.